Okay, so for 37, it's just like 36. It's just a different ratio, but it's also a negative ratio for sine. So to get the this first angle in quadrant 4, remember the calculator gives you that green angle in a negative direction. So you do inverse sine of the negative ratio equals, so to get the positive angle, you add 2 pi, and that'll give you that. To get the purple angle, the one in quadrant 3, you do start off the same way, inverse sine of the negative ratio equals, but remember it gives you the green angle with a negative, so you change the sign to positive by doing that, by doing the negative of the answer. And once you get that, you add pi, and you get the angle in quadrant 3. Okay, so for number 38, they did give you the interval 0 to 2 pi, so we're not going to give the general solution for this one. We're going to give answers that are only inside this domain. So, because these are not like terms, we cannot combine them, but I know we have a formula for sine 2x, which is 2 sine x cosine x equals sine x. Subtract sine x from both sides, so 2 sine x cosine x minus sine x equals 0. Now notice how they both have sine as a common factor, so we're going to factor that out. 2 cosine x minus 1. So set each factor equal to 0, so sine x is 0. 2 cosine x minus 1 equals 0. So this is cosine x equals 1/2. So sine, we know sine is positive here and here. So that means x is 0 and pi. And cosine is 1/2 positive here and here. So that's going to be pi over 3 and 5 pi over 3. Okay, so they're asking you to give sine of u plus v, and so here's the formula of sine of u plus v. They also gave you a couple of ratios. They told you the sine of u was 7 over 25, and that both angles u and v were in quadrant 2. Okay, so that's what you see right here. Here's 7 over 25, and cosine v was negative 12 over 13. So we're still missing a couple of values. When you do Pythagorean theorem, for u, for the triangle in u, you get negative 24. And it's negative not because you got it from Pythagorean theorem, but negative because of the direction, because it's the x value in quadrant 2. And then v, the y value would be 5. Okay? So sine of u, 7 over 25, cosine of v, negative 12 over 13, plus cosine of u, negative 24 over 25, times sine of v, 5 over 13. So you put this all, you simplify it. Okay, so you get, simplify the numerator, negative 84 minus 120, because remember it's negative times a positive, so you get a negative. Denominator 25 times 13 is 325. When you combine the two, you get this. Okay, so this one I set up a little bit differently, because for this one, I already put in the values that they gave us. So you guys were given these two values. So I just substituted the values ahead of time. And we still need to find the x value for angle u and the y value for angle v. So this is a 5, 12, 13 for angle u, so that's negative 12. And then v is a 3, 4, 5, so the y is a 3. So cosine u, you go to angle u, and it's negative 12 over 13. And sine v, you go to angle v, and it's going to be 3 over 5. And just like the previous one, you simplify. You get 48 minus 15 over 65, and that's going to give you 33 over 65. Alright, so for number 41, they want you to find cosine of 2u using a double angle formula. Remember, you have 3 choices, so of the 3 choices, given that they gave you sine u, I would use this one. I mean, you can use any of the 3, but if you use the other ones, you would have to find cosine. So for this one, you don't need cosine, you just need sine, and you already have it. So when it says u is between pi over 2 and pi, that's really not even necessary because you already have this value for sine u. It was given to you. So you would write 1 minus 2 times 7 over 25. Remember your order of operations, the square goes on sine u, so that would be right here. So you would square this first, so it would be 1 minus 2 times 49 over 625. So that's 1 minus, 98 over 625. And then when you simplify that, I mean, you could just put it in the calculator or write it as 625 over 625. That's your 1 minus 98 over 625. So when you take the difference, you get 527 over 625. Okay, so for 43, we're going to use the double angle formula to substitute for this. So we have 1/2 2 sine x cosine x equals cosine x. Now notice 2 times 1/2, when you multiply them, that becomes 1. I'm going to subtract cosine x from both sides, so I have sine x cosine x minus cosine x equals 0. I can factor out a cosine x from both sides. So you have sine x minus 1 equals 0. So then you have cosine x equals 0, or sine x minus 1 equals 0. You solve for sine x, and we know that cosine is positive here, I mean, sorry, not positive, but 0 here and here, and sine x equals 1 up here, right? So it doesn't matter, the two answers overlap, that's okay. X is pi over 2 and 3 pi over 2. Okay, so I got this line from, this here is from the product to sum formula. That 4 is this 4 right here, and so I put braces, or actually brackets, to separate them. And again, like I said, this is the equivalent of this, okay? So now we're going to simplify each argument. We're going to add these together and subtract these. So we get, and then 4 times 1/2 is 2, right? So we're going to put 2. And we get sine, this is 4/2 plus, let's see, that's about 2, sorry, 2/4, I said it backwards. This is 2/4 pi plus 5/4 pi, so that's going to give you 7 pi over 4. Minus, right here, this is 2/4 minus 5/4 gives you sine of negative 3 pi over 4. Now remember, when you have a negative angle for sine, that negative, because of the even odd properties, that negative goes to the outside in front of the function right here. So there's a negative there already, so you end up with 2 sine 7 pi over 4 plus sine 3 pi over 4. And that would be the final answer right here. Okay, so for 45, remember, sine of 90 plus sine of 70 is not equal to sine of 160. You do not add the angles like that. This is the formula. Again, I've already substituted the values. Check your notes. And so all that's left to do here is simplify. So 2 sine 90 plus 70 is 160, divided by 2 is 80, times cosine 90 minus 70 is 20, divided by 2 is 10. And that would be the final answer. Okay, so this is another sum to product problem. Remember, cosine of 3 theta plus cosine of 8 theta does not equal cosine of 11 theta. It equals this, and again, I just used the formula. I picked the right one and substituted the values of A and B, or angle A and angle B right here. So now we just have to simplify. So this becomes 2 cosine 11 theta over 2, so this, it doesn't, you could leave it as a fraction like this. And then 3 minus 8, so that would be negative 5 theta over 2. Now for cosine, that negative doesn't go to the front, because remember, with the even odd properties, cosine of negative theta equals cosine of theta. They have the same value. So that cosine just kind of disappears. So 11 theta over 2. And cosine, yeah, you're not supposed to leave the negatives in the angles like that. You have to use the even odd properties to simplify. So that's the final answer. 47 is just like the previous two problems. You just have to make sure you pick the right formula. Sine A minus sine B. And it does not equal sine 2 theta. You do not subtract the theta from the 3 theta. So now we have 2 cosine 3 theta plus theta is 4 theta, divided by 2 is 2 theta. 3 theta minus theta is 2 theta, divided by 2 is just theta. So it's just sine theta, and that would be the answer. Alright, so for 48, I've set it up already for you. So this was asked, right? This is the question. Remember, this represents one angle and this represents another angle, because tangent inverse of a ratio is an angle. Sine inverse of a ratio is another angle. So I'm just calling it A and B. So here's angle A. Tangent is y over x, so there's a y, there's the x, and sine is y over r. So we're missing some values. For angle A, it's 4 plus 9 is 13, square root of 13 is right here for the hypotenuse, or the r value. And for the x value on angle B, that would be 49 minus 16, right? So this would be the square root of 33, right here. Pythagorean theorem. Now I already substituted sine B as 4/7 because right here, it's for angle B, the sine inverse is 4/7, so that's sine B right there, 4/7. Okay? Cosine of A, you go to angle A, and it's going to be 2 over radical 13. Cosine of B, you go to angle B, and it's going to be radical 33 over 7. Minus sine of A, you go to angle A, negative 3 over radical 13. Okay, simplify this and you get 2 radical 33 plus, because you have two negatives, 12 over 7 radical 13. So I'm going to rationalize this by multiplying top and bottom by radical 13. I don't have to use the 7 because that's not in a radical, so you can leave the 7 as is. So we distribute here, so you get 33, let's see, so 33 times 13, 429, so 2 radical 429 plus 12 radical 13, and the denominator is 13 times 7, so that's going to be 91.